Hi everyone! We continue to delight you, our users, with updates and improvements so that you could have the best user experience in our application. Today, I will cover the changes on the analyzer side from the version 5.4 till the version we've just released, 5.6. Hope you will enjoy our latest version. In the previous versions, auto-analysis worked only with an automation bug, system issue, or product bug defect type groups, together with custom subgroups. But users asked us to add no defect and custom to investigate defect types to speed up their manual processes. What are the reasons for the usage of those defect types? They could be flaky tests, or users wanted to stop analysis of the failure for a short period of time, or they wanted to assign the same failures to a certain group of users for investigations. In older versions, we didn't want to add those defect type groups, not to disturb the model with a noisy input, as far as any log labeled as no defect could be at the same time a system issue or a product bug or an automation bug. But we decided to add a slight change in the auto-analysis process to allow to work with these defect types as well. For these defect types, we consider only history items with the same unique ID as candidates. The latest test item with similar logs should be of these defect types to be used for analysis. If the latest test item with similar logs has a standard issue type, then auto-analysis will be applied in a normal way. So as you can see in the picture, the latest test item number 2 has no defect issue type. And the model gives probability more than 0.5. That's why the third test item will be labeled as a no defect. Now let's demo the first case. We are applying no defect for test item assertion error and custom to investigate for test item null pointer exception. So now the launch has 2 test items with defect types. I'll run auto-analysis for the second launch. And it worked as expected. Test item assertion error got no defect type, whereas test item null pointer exception was labeled as custom TI. In our standard auto-analysis process, when a failed test item has several logs which have stack traces or their log lines number is 3 or more, we will match history test items by any of them. But users provided cases when it's important to match by all of them. That's why we added the setting in the auto-analysis settings tab. By default, the toggle for the setting all logs with 3 or more rows should match is in the off mode. But you can turn it on to have stricter rules for the analysis. Let's see how it works on the example. We have one test item with a WebDriver exception log and have another test item which has 2 logs with WebDriver exception and assertion error. Now in this section, similar to investigate, the first item is shown as far as we have one common log. Let's apply system issue defect type for the first item and run auto-analysis. The second test item got the label system issue as far as we have one common log. But if we turn on the setting all logs with 3 or more log lines should match, we will get a different result. Let's reapply auto-analysis. The second test item won't be labeled as a system issue because it has 2 logs and have only one common log with QI except test item, so they can't be matched. And in the section similar to investigate, the first test item also won't be shown due to the turned on setting. Due to the structure of the logs, we can extract some important information which is relevant for many projects. We found out that in most cases, test items have the same reasons for failure if they have the same exceptions or errors. So for auto-analysis or while searching similar to investigate items, a candidate should have the same exception as investigated test item. For example, the first log should match with the log where org.com.nullPointer exception exists, and the second log should match with the one with java.lang.assertion error. In the API logs, status code information is very important. That's why we extract numbers after the keywords code or status as potential status codes. This helps to reduce the false positive matches for API logs. And you can add keywords, status, or code before important numbers so that we could match by them. From the version 5.5, we've introduced a new functionality, machine learning suggestions. These things help you in the manual analysis. It suggests you up to 3 options from the history which have a similar reason for failure. You can choose any of them, and a defect type, issue description, and Jira tickets will be copied to the investigated test item. The suggestions model has more features in comparison with the auto-analysis model. As far as it is run for one test item at a time, we can have a more powerful model without problems with performance. The model is less strict to give you more options to choose from. The option probability gives hints on how certain the model is about its decision. If the option probability is 100%, it's called same. If the option probability is from 70 to 99%, it's called high. And if the probability is from 40 to 69%, it belongs to the low probability group. Machine learning suggestions help not only find reasons for failure more quickly, but also specify positive and negative examples explicitly for our models, and it is easier to retain custom models for your projects on these examples. In the previous versions, we added retraining for custom defect type language model, which is used as a feature for global decision-making model. Due to ML suggestions, now we can retrain booster models for auto-analysis and ML suggestions. What training data do we gather? Test items with defect types are used for candidate generation in auto-analysis and ML suggestions, and retraining a defect type language model. This model is described in the previous videos. Now let's talk about the data which is used for retraining models for our main functionalities. We gather both positive and negative examples while you interact with the system. When you choose ML suggestion, it's a positive result for the model, as well as when you don't change a defect type for the auto-analyzed item. When you choose at least one suggested item, the other suggested items are considered negative. This will balance the model. If you don't choose any suggested items, the model will think the suggestions are wrong, so they should be corrected in further training. When you change a defect type for the auto-analyzed item, the model result will be considered as negative. By balancing positive and negative examples and finding patterns in the data, new custom models will be trained to reflect your project needs. In the previous video, we gave instructions on how to set up the analyzer train instance together with Minio or a file system, so that you could use our functionality to the full extent. This picture shows how models are saved in Minio. There are folders with models, and here are the save trigger information for retraining. Each model is trained and saved per project. As far as we retrain custom boosting models for our main functionalities, we can add more information specific to your projects. For example, launch names and test item names. The model can find different patterns for launches used for UI and API tests. Or some message and stack trace words can give more boost to similarity by message or potential status codes than others. All the mentioned patterns are trained on your interactions with the system and customized for your project. Here is the example of potential features which could be used for retraining custom models. And the custom model will give better estimations for the test item to be similar to historical test items with both defect types. Now I'll show you how ML suggestions functionality looks like. We have 3 test items with similar logs, one with more similar and other with less similar logs. I'll choose an automation bug defect type for the test item with more similar logs, and a product bug for the one with less similar logs. When I open the test item assertion error, I can see 2 suggested items, and scores are meaningful. The more similar test items are, the higher the score is. To show you the logic about potential status codes, I'll show these 3 test items. One test item has a status code 409, and other 2 have a status code 513. When you open the first test item, you won't see test items with other potential status codes, even though the logs are quite the same. The test item with 513 status codes will be both in the Similar to Investigate section, and when I apply a system issue for this test item, the second item will get it as ML suggestion. Our experiments showed that, on average, all the described changes gave plus 7.2% improvements in comparison with the previous version. These metrics were calculated on the 14th project's data. Let's summarize. We've implemented auto-analysis logic for no defect and custom to investigate defect types. We've added restrictions for potential status codes, errors, and exceptions to make fewer wrong decisions. We've introduced a new functionality, ML suggestions, set up retraining for all models, and added more personalized features specific to the projects. So you, our users, will have a more accurate analysis via a personalized algorithm. The more you interact with ML suggestions, the more training data is gathered for retraining customized models. I hope you enjoyed our improvements, so don't hesitate to update and explore new features in the application yourself. If you have any questions, please leave a comment below or ask a question in our Slack channel. Thank you for your attention and take care.